Okay, this is the part 2 of the lesson video on 21.0. So previously we have learned how to define the sign convention to define 3D space. What does it mean by the vector going out of the paper into the paper? What is the sign convention used, the dot and cross? How we move on from magnetism and extend our knowledge, and then now we have electromagnetism. And how do I now that I know that the current will actually induce a magnetic effect. If you don't want to use the word induce, you can use produce as well, but ideally should be induced because it is a temporary change. Once the current is gone, the magnetic effect is gone, right? So now we know that the magnetic field is circular in nature, right? Some of you may be wondering how you know it's circular in nature. Now, do you remember in the magnetism chapter, there is a part where I share with you how they know that the magnetic effect is like that, right? They put tiny compasses around and then they align the compasses to actually form this line, correct or not? So they do the same thing for this. They go and really put the wire like that from the floor to the ceiling, and then they put tiny compasses around the wire. And after that, right, they observe that, oh, actually these compasses, the arrows, right, will align to form a circular shape. Okay, so if you want to know more, read your textbook. That's what your textbook is for. It's for me to be irresponsible and just tell you to go and read the textbook, because it's just a description of the experiment. So go and read. Okay, if not, you want more interesting ways to describe this experiment, right? Just Google or YouTube. Okay, you can find out how they come up with this circular magnetic pattern when there is a current flowing through a conductor. Okay, now in part 2, what we want to say is, okay, now I know that this magnetic field pattern around the conductor with a current flowing will be circular in nature. So magnetic field line, you all learn, right? Magnetic field line, I have to make sure that I have arrows, right? That the general rule is that it's an imaginary north pole, so it will be like that on the right hand side, and then the south pole it will be like that. So how about this circle thing? Which one will be north pole, which one will be south pole? Now to do that, we make use of a hand sign that will facilitate us in memorizing. It is called the right hand grip rule. Dun, 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 dun. Okay, right hand grip rule, I must warn you first, there are 2 variations. Okay, I am just teaching you the first variation. In the first variation of the right hand grip rule, the thumb, right, will be indicating the direction of current flow. So this is your current, and the rest of the finger here is indicating to you the direction of the magnetic field line. So you can imagine it like Wolverine, from the finger that are crossed, and you can see that the direction of the cross matches with the magnetic field line. Okay, so we say that the curl of the finger, right, will correspond to the direction of the magnetic field lines. Okay, so of course when you draw this, right, the gap between the magnetic field line actually will get bigger, because the field is stronger the nearer you are to the wire, right? So actually the field will actually, the strength of the magnetic field will actually weaken as you move away from the wire. Okay, so now what we know is that, okay, let's try this. I will put all 3 content into one exercise. Okay, first content is the sign convention, how to determine the direction of the conventional current. Then after that, use your right hand grip rule to decide what is the direction of the magnetic field. So now I have this, right? I have the positive terminal here because this links to the positive, and then I have the negative terminal here because I link to the negative terminal of the battery. So the current flow will be from bottom to the top or top to the bottom, right? Conventional current flow says that it is like this. So this is the current, right? Now use your right hand. For those who cannot differentiate left hand or right hand, please use the correct hand, the right hand. Align the thumb to the direction of the current. So your thumb should be like that, right? And you will see that the rest of the finger will be curving like that. Okay, very hard to draw lah, right? As if you are curving on a rod, right? When you are holding onto a rod, wow, cannot tahan sia, so ugly. Let me try my best. Like that, right? This finger look like, sorry, 强迫症. Okay, like that, like this. Okay, extremely long thumb. Extremely long thumb. Okay, don't go and Google what you mean by extremely long thumb. Okay, so now your hand, right? If you are using the right hand, this is what you will get. Okay, you will see that the thumb actually points down, aligned with the direction of the current, right? Then the curl of the finger will suggest that the magnetic field line goes like this, right? That is what you imagine now lah. So now you need to translate what you imagine onto this piece of worksheet. So first of all, in the rod, the paper, right, is going from the ceiling to the floor, right? And if your eyes is here, you will see a dot or a cross. I give you 3 seconds to think. A cross, right? So this is your eye, correct? Then using your right hand grip rule, right, you know that it is going to be circular. So circular, okay, no need to draw too many, just one will draw about 3 rings will do. Don't draw too many. Okay, just make sure that the ring, the gap between the rings gets bigger and bigger. Okay, if you can freehand, you can freehand. If you cannot freehand like what I'm doing, then please use a compass. I'm talking about you, the boys who can't draw. Okay, so once you do that, then you indicate your direction, right? So if you use your right hand, okay, I can't draw also. Okay, you use your right hand grip rule, you will find that you are having a ring that goes like this, right? This is the clockwise. Yeah, okay, so that's one. I want you to try this on your own. Okay, on your own, I want you to try this. Can? Okay, after you do that, you come back for the third video.